WWT presents Partner Spotlight.
Hey everybody, Mike Trojecki here. I am the Senior Director of the AI practice at WWT. I'm excited to welcome you to another Partner Spotlight brought to you by WWT Presents. I think we all know the AI revolution is here. Things have changed dramatically over the last year or so. It's transforming industries faster than ever before. I know with all this great innovation though, there definitely comes some challenges, especially for some of the data center teams. So the data center of yesterday is really no match for the AI factories of tomorrow. Power, cooling, scalability, integration, future proofing. There's so many details, big and small, that go into building an AI-ready data center. Stakes couldn't be higher. Lucky for us, we have a tremendous pair of experts with us today to help walk us through it and get you on track to AI success within your organization. I'm excited to be joined by some friends and collaborators, Joseph Reele, who is the Vice President of Solution Architects at Schneider Electric, and Ahsan Yousufzai, NVIDIA's Global Head of Business Development and Strategy for Generative AI. Joseph, Ahsan, thanks for joining me today.
Thank you for having us.
Yes,
You're welcome.
thank you for having us.
So, guys, let's jump right into it. This landscape for AI is evolving so rapidly. It's hard for many of our joint clients to keep up. You guys are as plugged in as it gets as it relates to AI insight. What are you both hearing from C-suite leaders as it relates to some of the challenges of jumpstarting or scaling AI solutions?
Ahsan, would you like to go first?
Sure. Okay. So first of all, thank you, WWT and Mike, for having us. I really appreciate. So when we're looking where we are heading towards, right, or what is going on in the market, we need to divide it into two areas, right? Pre-Chat GPT and post-Chat GPT, how AI has been used. If you look at the pre-Chat GPT time, most of the AI inside the enterprise was used for the cost saving perspective, right? If you look at it in the energy vertical and the manufacturing, right, people were trying to do cost savings, doing the predictive maintenance, inspections, and things like that. But post ChatGPT, the whole landscape has changed, and people are actually using AI, Gen AI, to bring efficiency and optimization, which results into a lot more revenue. Now, everybody wants more revenue, everybody wants more profitability. And that is created a huge shift and forces the whole enterprise to adopt Gen AI much more faster. And that leads to another the bigger problem, or the major problem among many other things, is the scale and the availability of infrastructure to do that. We are seeing a lot more. I mean, every company is actually trying to build their own AI factory, may that be on the cloud or on-prem. They are investing heavily in this space. Now you don't have space available. A lot more tier 2, tier 3 data centers, colo locations coming up, which needs to be built faster, optimized, and in a sustainable fashion. So this is really the crux where the industry is facing right now.
Yeah, thank you, Ahsan. And hi, Mike and Ahsan. Thank you on behalf of WWT and NVIDIA. Certainly, Schneider Electric. Super happy to be here and glad to be a partner of both of your organization. So thanks for having us, Mike. That's a great question. I've literally been across the globe this year, almost 130,000 miles, believe it or not, in the airplane, which is way too much. But the question that you asked is the question I'm being asked almost daily and weekly. So I was just in Canada, top 3 banks in Canada. And that's kind of what Ahsan was talking about is, well, how do I participate? How can I adopt? And that's one of the words Ahsan uses. How do I adopt or adapt my facility and my IT kit, right, to participate in this? And it's a very complicated situation because, think of it this way. I don't know, don't quote me on the number, but there's millions of data centers in the world today. And those data centers has traditionally been built in a cloud architecture, meaning a much lower density per cabinet. Whether it's ChatGPT, AI, quant, machine learning, augmented reality, name it, this is a much denser compute environment. And what that really means is, yes, you can do more with the compute because it's more powerful, but it requires, as you densify the compute, you densify the power. And so power distribution becomes a challenge. And as you densify the compute, which then densifies the power, it's physics, everybody. More power, more heat. Well, now we have to figure out how do we cool. And so if you think about this entire situation, it's an ecosystem. It's compute, it's network, it's storage, it's power, it's cooling, it's reliability. Oh, by the way, it's cybersecurity. And Isan mentioned also we need to be doing this with the lens towards sustainability as well. And so that's the questions constantly by all businesses, enterprises, government, co-location, even hyperscalers, is how do I either adapt an existing facility to accommodate some of this, or how do I have a new design that would accommodate a purpose-built thing? And just not to be incredibly technical here, but none of us have to be a rocket scientist to figure this out. Cloud era is 10 or say less than 20 kilowatts a rack. Okay, that's a design, that's a thing. If I were to do 100 kilowatts per rack, do you think I should use the same? We don't have to be rocket scientists to go, no, that's 5 times the amount. So there's different compute, network storage, power, and cooling technologies to handle all of this. So these are the challenges. It's a business problem, okay? It's a business challenge. For those that don't or can't participate, it's probably a drag on their business. They're not going to be as competitive. They're not going to be as optimized, as efficient, etc. So, so these are incredibly important questions that we're being faced with. And the good news is, I end with the good news and turn it back over to you, Mike, is that, I say this often for those that maybe listen or follow me sometimes, nobody makes soup with one ingredient, right? That's just chicken broth. All right. In order to make a gourmet soup, you need a lot of different ingredients. The moral of the story is you're looking at 3 impactful ingredients to make the solution easy, affordable, and efficient for our clients. And that's between WWT, NVIDIA, and Schneider Electric. If you were only to visualize this, that's 3 legs. Imagine sitting on the stool that only had 2 legs. It's probably tippy. Imagine sitting on that stool with only 1 leg. It's even tippier. So how to solve these very complicated challenges, from power to compute to network to cooling, is with the ecosystem of partners that you're looking at really today.
Yeah, and Joe, that's a great point. And we look at it and we see it from our side too, from a WWT perspective, is these challenges of having the data center, the availability, the space, the power, and the cooling to really deploy these solutions it's an absolute necessity. So let me ask this question then. You talked about ingredients, and of course the ingredients from WWT, our services, and the products from NVIDIA, products from Schneider Electric. There are other ingredients there. So when we look at the data center and the data center infrastructure, what needs to change in the data centers to address those challenges?
Yeah. Um, a couple of things, and Isan can probably add a lot more color, but um, if we start just with the simple thing, the network fabric of a AI environment is significantly different than the network fabric of a cloud environment. So, um, so in a nutshell, these are purpose-built environments. Even if it's in a brownfield environment that was built for lower density, you have a purpose-built area or a pod that can handle the compute density that NVIDIA comes with their great GPUs and combination GPU slash CPU as well, right? Um, and so this is really a purpose built thing. So it starts with the network, which then drives the concentration or the densification of the compute. So in the rack, and Hassan could talk about this, there might be 72 servers in one rack, all one. And by the way, this one rack, in the old days, in the cloud era, 72 different servers operated 72 independent ways. However, in this one rack, all 72 servers actually wire or operate as one. And how that's accomplished is via the network. So therefore, the network architecture is totally different. In order to handle the power density, the power distribution and how you distribute power to the rack is totally different as well. And then how to handle the cooling aspects of it. So once again, a very and Hassan could probably talk about this, but really a keen eye to developing the environment to house the solution is the right answer. You really can't do it any other way, um, and do it cost effective with the risk that you're needing. And the way you kind of maybe want to look at it abstractly, just abstractly, um, you know, we can all talk about pick your car, a Lamborghini, or you know, um, fancy race car. But guess what? It can be this beautiful thing that you look at, but if it doesn't have tires on it, it doesn't go anywhere. And so this is the story. This is the thing. It's a purpose built, keenly aware what we're trying to solve, and it's being solved by three independent entities working as one.
Yep.
Okay. If I just went in there, handle power with a blind eye to what Ahsan needs, or with a blind eye with Mike, what you and your team are leading, then guess what? It's kind of like having a car with no tires. So, so that's really, in a nutshell, kind of what we're doing. Ahsan, you want to talk a little bit on some of the things I just mentioned? I probably skated at a super high level there, but
No,
Yeah, and I'd like to hear from Essen on that, because now we are talking about the Lamborghini, right? We're talking about that high performance car, and when we look at NVIDIA and some of the things that are happening in the data center space and moving from traditional data centers to AI data centers, Essen, what are some of the things that you feel need to change to address some of those challenges?
so some of the things Joe talked about, how, and then he mentioned that these systems are no more uh, operating as a single individual node or computer. They're not just even operating as a full rack. You need a full data center as a one computer to train these large language models. The math and the physics changes dramatically. How you make everything work as a single computer. The While the compute density is changing, you know, you need to really understand everything from cooling the space and everything. You you also need to put those things together in a fashion that, as you are building these models and you are doing both, not just training, inference. Inference in the Gen AI is even a bigger thing, more than the model training, because you will be doing inference 100x or 1000x more than you're going to train. So there will be a constant use of the compute resources. This is where we don't need to just look at the single, how much of the compute or power consumption at a node level, at the rack level, but as a holistically. So you have to simulate everything. You have to really bring those things before you even build those things. So a lot of things we are doing with WWT, which is fantastic, and I've been involved in a couple of these great projects which WWT is doing, and I'm being very deeply involved with the Schneider Electric. Hey, how do we, as we are building this thing, how do we bring all these very large ecosystem players, all those components comes together as a one system, operate as a one system, and there the technologies like Omniverse, where you bring all these CFD, electrical system, cooling system, you name it, into one single place and simulate, and then you build it. You build it in a one go and right. That's the thing. So this is a really a key piece, that how we're building those things. We should simulate, design, and build accurately, and that's where WWT plays a major role.
Joe, you had mentioned earlier talking about cooling, and we look at the world that those data centers are in. It's the cooling piece is obviously critical, along with the power, not the space, and just even the weight. But I know that Schneider Electric and others, you guys are looking at how to cool these data centers in a different way, right? It's not just air cooled anymore. There's other technologies that are out there. So do me a favor and do the audience a favor here. Give us an idea of what some of those kind of cooling technologies are, those innovative cooling technologies that we're going to use to support these AI data centers.
Yeah, thank you, Mike. It's funny because years ago, I've been in the industry a long time, and I could tell by the all of us on the phone, we all have. And liquid cooling has been talked about for a long time, and it's for a couple of things. Number one, liquid cooling is for real. That's an absolute truth, and it really is, I'd say, one of the keys that enables the densification of the compute and the demands of the compute. And so, traditionally, for those that don't know, 99.9% of all data centers across the entire world, forget supercompute places, but general data centers have all 100% been cooled by air cooling. And that is, think of it, a low temperature chilled water system with a coil and a fan, essentially. There's other ways to do it, essentially, but then you use the air as the mechanism that collects or transfers the heat. Now, that's been good for about, let's say, 20 kilowatts a rack. Somebody could say maybe 30, 40, fine, okay, all right. But what Ahsan and his team are they have compute that's capable of north of 100 kilowatts per rack. Okay. To move that amount of air in that small of a space and do it efficiently is we'll say impossible or not possible, which is why now we are deploying liquid cooling. And there's, I would say, high level here. Okay, I'm not trying to be an engineer for everybody here, but I just want to paint the picture. There are 4 maybe main ways to use liquid cooling in the data center. You hear the term direct to chip. And essentially what that is that the GPU is the chip. And on top of the chip is a cooling plate. Kind of think of a radiator of your car, for lack of a, all right? It's just a hollow tube, if you will. And cool water would transfer through the little tiny plate on top of the chip, removing the heat from the chip. That's direct to chip. A couple of things to make note of. Storage equipment is not direct to chip yet. Neither is network. And for those in the data center industry, you would know then, well, wait, hold on. In order for a data center to be really a data center, I need compute, check mark, that might be direct to chip, but I need network and storage too. So if you're reading between the lines, the data center of today is a hybrid solution. It is essentially a portion of the data center that is purpose built for AI is going to be air cooled, network and other things I mentioned. And then the GPUs would be direct to chip. Now, that's one way to cool with liquid cooling, direct to chip. Another way to cool with liquid cooling, okay, is a rear door heat exchanger. Essentially, instead of the chip being on the server itself, just think of it enlarged to the size of the rack, and you have a radiator on the back of the rack, essentially. Again, right at the source of where the heat's being generated. That's the second way with the liquid cooling. The third way is full immersion. Essentially, instead of the liquid being contained in a small chip or within the coils of a rear door heat exchanger, the whole server sits in a bath of liquid cooling. Now, the first two that I just explained, direct to chip and rear door heat exchangers, are today more prevalent, are more predominant, as widely deployed versus in immersion, the whole thing. There's some technical challenge with immersion cooling and those types of things we won't want to detail here, but liquid cooling is in fact in play today, in operation today, in data centers. Now, 5 years ago, we wouldn't have said that. We would have said that maybe for a supercomputer in the University of Madison or something like that. But we certainly wouldn't say that in a quote unquote normal data center. Whereas today, we see that, in fact, it's a requirement in any dense application that uses GPU and that has a GPU direct to cooling mechanism. Okay. So that's a significant change. Okay. And by the way, I'll just say this because I think it's really important. High level, forever, the IT kit in a data center has been on UPS system, uninterrupted power, never go off. If the power goes off, it goes onto a battery. Fine. Okay. There are in AI training where maybe the IT kit doesn't get the UPS battery backup. It's just straight power with no battery backup. While that, you might think that, okay, wow, that's awesome, cool. If it is direct to chip, the power goes off, the chip was working. If the pump shut off at the same time the power shut off, you just blew up the chip because you couldn't dissipate the heat. Haha. So now, okay, why do I say that? Well, because the power architecture of a data center never really contemplated mechanical equipment on uninterruptible power. Very rarely, you could always find the case that somebody did or did, but by and large, mechanical systems were not, quote unquote, never off in design. Ha! Well, wait. In an AI data center, even if the IT kit doesn't have that battery backup, and it's an and statement, I am direct to chip cooling, there needs to be contemplation on never off or battery runtime of the cooling system, in particular, the loop system that's driving the water to the chips. If that goes off, in other words, no cooling being pumped, and the chip is hot, I don't think we have to be a rocket scientist to go, well, that's a problem. I have the heat that needs to be removed, but I have no cooling medium to do it. And by the way, you might want to think about that because I'm not sure, but I think that those GPU chips are thousands upon thousands of dollars per chip.
Yeah, absolutely. And if you look at that and you look at all of those different things, I want to get Essen's take on this as
Yeah,
well. But you
please.
look at you know building forward, and as Joe, I ask you a similar question after this is, when we look at this and we're trying to scale these data centers and we run into these issues from a cooling standpoint, we run into these issues from a power standpoint. You know, Essen, talk to me about how you guys are using reference architectures to help our customers build these environments that can really handle all the immense power, the cooling, and connectivity needs.
Great question, Mike.
Mhm.
I think the way we are is we are building these AI factories, and they're building them more rapidly and fast. There's a core need to have standardization when you're going and building those things. And that's where the reference architectures become so crucial piece to it. And reference architecture for everything, not starting from when you are designing the data center, when you're doing the electrification, you're doing the cooling, even up then taking forward when you're building those models, and doing the inferences. So throughout you need to have a standard reference architecture so you can build once and deploy many times easily. The goal, I think, if you look at the North Star, what is happening, how what Elon Musk did, building a supercomputing, the whole data center with 100,000 GPUs in 19 days. And this is not possible if you don't have those standard reference designs and architectures. And Joe mentioned, talking about the chip, power of the chip. It's talking about the chip to grid. This is very important. And I know WWT work a lot of those things in building those data centers. So we need to fully understand what is happening outside, the data center wall, which is in the substation, then to the transmission grid, to the generation. So all those things needs to have a cohesive standards and architectures to go and build those things. We are in the business of producing intelligence now, and the more intelligence we need, the more and we have to apply those intelligence in building those data centers and AI factories.
So, and that's a great point. And you talk about the reference architectures and kind of using that as a guide. But Essen, if you're an enterprise that's out there and looking at AI, what are some of the first steps that they should take? What are some of the things that they should be doing when looking at data center readiness, right? What are some of the things they should do beyond kind of the reference architecture? And Joe, I'll follow up with you on that same question.
I think the first thing they should get WWT is basically come and assess,
Right?
do your readiness assessment. Are you ready to embrace the Hopper to Blackwell, architectures? Are you ready for that? Do you have the enough power, space, and cooling things, right? So this is very, very critical. And WWD have done, because I work with them, this is an amazing job doing that, right? And we really leverage them as one of our platinum partner to go about doing those assessment. Make sure there's just so many, networking and storage, these are some crucial pieces. And there was, I think, you, Mike, and Joe, you both talked about having a Lamborghini. It's of no use if you don't have a road, if you
Right.
don't have a track to run that. And having the high speed storage, how they're connected and we link, InfiniBand fast to the GPU, so work as a single computer. So this is a crucial piece where WWT, the kind of experts they have, really rise and shine and advising the customer as they're building or using a colo location even for doing those things.
And Ahsan, you get the prize for best response of the day. So as they say, the check is in the mail for you. Joe, what is your take on that? What do you think we should be doing for our customers and where they should start when looking at their existing data center infrastructure?
Yeah, I mean, I don't want to take the easy way out and said everything Nissan said, but he was 100% accurate. Let me add a couple things though. There's a business outcome that our client is anticipating. They're not doing this because they're just going to do it because they're following the leader. There's a business need. There's something they're trying to solve. There's and so the first thing, again, through WWT, is really sitting down with the client to figure out what's the business need. What are you doing? What are you trying to solve, and how are you trying to solve it? Right. That's the now. Second part of the conversation is where does that look like in 2, 3, 4, 5 years from now? So as a business consultation with WWT, NVIDIA, and Schneider, we're sitting with their client to determine what their business outcome and desire is within their risk profile. All right. So that's number one, on top of what Ahsan said. Then, okay, now we understand the business need, the outcome that they're trying to achieve, okay, and the time frame at which they want to achieve that in. Now then comes the magic between NVIDIA, WWT, and Schneider. Now we need to go take a look at, if it's a brownfield environment, to Ahsan's point, we need to go assess that. And from multiple different angles, one from network, then storage, then space. I'm talking about square footage space. I'm talking about power capacity. I'm talking about diesel generator capacity, battery capacity. You need to have a look at what the environment is, okay? And can it support what the anticipated business need is? Because between WWT, NVIDIA, and Schneider Electric, that solution set that gives them that business need, let's just say they want to be in the AI world with chat things. Okay, fine. Well, WWT and NVIDIA is going to figure out what that kit is required in order to do that. Power cooling is going to be required in order to enable that and light it up. And then we have to go figure out, where do we put that? All right. So that's kind of the process in which we go through this with our clients. And by the way, imagine if you just went to look at cooling. And when we said, yes, cooling can handle it. But then the client goes, yeah, because cooling can handle it, but now power and network doesn't. Okay, so again, that story of, hey, you know, in the old days, businesses, NVIDIA, WWT, Schneider, and I'm just giving some abstract examples. We operated like the Kentucky Derby. The best athlete in the world in lane 1, another one in lane 2, another one in lane 3, another one in lane 4, another one in lane 5. And we had an objective. On your mark, set, go, the gate open, we ran straight forward. And by the way, we had blinders on. The real Kentucky Derby has blinders. What we're doing right now is saying, hold on, time out. The problem that we need to solve with our mutual clients in enterprise, government, colo, hyperscale are getting more complicated. And the time at which they need to be solved is getting shorter. The business need is getting greater. So what it's allowing us to do now is, instead of operating like the Kentucky Derby, with NVIDIA going and then WWT going and then Schneider going, well, then NVIDIA, WWT, and Schneider, instead of individual horses, they are still individual horses, but they've been roped together. And now we're riding a chariot versus trying to win an independent race with an independent horse. The problems are too complicated today. The technology is getting more complex. How you utilize, deploy, solve, and design to the most optimum efficiency with the lowest risk equal to your client's risk appetite requires this ecosystem to work together. So this is how we do it. We get the question, we validate the business need, we go assess, and then based on the assessment, the three teams get together to put their best foot forward on a design that can accommodate A, the request, B, where it can fit.
Yeah, and it's an amazing partnership, right? And I think those people that are out there and organizations that think they can do this on their own, I think they're mistaken. This is a team sport when it comes to AI. It's a team sport when it comes to the power, the cooling, the space pieces of it. It's just we need everybody, all hands on deck, to really support each other. So I love the analogy. So, gentlemen, we could keep this going for hours. We're coming up to a close here. I wanted to thank the two of you for taking time out of your day to meet with us on WWT Presents. For the rest of you, thanks for taking the time to watch us, whether you watched us on WWT.com or another platform. If you'd like to learn more about that partnership between WWT, NVIDIA, and Schneider Electric, go to WWT.com. We've got a lot of great resources. There are articles, research, videos, labs, and a bunch of other assets that all touch on AI in all parts of the organizations. So thank you very much for watching, and we'll see you next time on WWT Presents.